On, was it page 10, number 1? You have a circle. Should look something like this. If there's a rectangle inscribed in it, then maybe something like that. Okay. Now, they wanted you to find a function for the perimeter, is that right?
Yes.
Okay. So here's what do we know either of the dimensions for the rectangle?
No.
So I'm going to call the width x, length y. What else do we know in this problem?
It's a rectangle.
The diameter is 24.
So I'm going to connect the diameter, make it 24, and we want a function for perimeter in terms of one variable only. So I always like to use function notation because this is going to tell me if there's any problems with my model. P for perimeter. Okay. Currently, if my length is x and my width is y or vice versa, what would the perimeter equation be? 2x plus 2y. Okay. What is the problem here if I want a function of x?
You have a y.
I have a y here. We don't want a different variable. We want only x's. So is there any other equation that I could use from the picture I drew? Yeah.
X squared plus y squared equals 20.
Good. That's just the
Pythagorean theorem.
Pythagorean theorem. Okay. So since we have this, what we can do is utilize this equation, figure out what y is going to be, and then replace it in the first one. So how do I get y alone here?
Minus y squared.
Minus x squared. So then y, we square root it, right? So 24 squared is 576. I do not need plus or minus because this is a length. Lengths are never negative, right? So this is y. And now if I go back to our function here to answer the question for number 1, a model that has just x in the model would be 2x plus 2, not y, but 2 times the square root of 576 minus x squared. And this is all we're doing in this section. We're just setting up equations or functions that model certain scenarios. We're not solving for anything yet. That'll be later. Right now we're just going to get practice in setting these up so that there's only one letter or only one variable. Yes, Paulina?
Can't you just square root everything so that it's y?
Good question. There's a minus here.
Ooh.
So you can't, this is not the same as this.
Well, no, before you even do anything.
Pardon this interruption. I'd like to thank teachers and students for participating in today's course recommendation day. 9th period teachers, please be sure to remember to bring all.
Anyway,
course
my point is that
recommendation
you can't
sheets
square
from
root
your
when you're
students
subtracting,
being
whether it's
collected
here or here.
to student services at the end of the day. Again, if teachers
Here.
in the last block can please collect
What about
all the course recommendation sheets and bring those down to student services as soon as the bell
Because you're
rings.
subtracting.
Thank you very much.
No worries.
Or up here, square root the whole thing, because you're adding.
I see.
You can only square root if it's all multiplication. Okay? Any questions on this first one?
No.
Pretty easy, right? Can you refresh my memory? What's number 3? We'll do 3 together.
Let P comma P parentheses.
Okay, so here's what I remember now that P is a point on what? Okay, so for those that are watching, we have any old point on the square root graph. We don't know the coordinates, so we're going to call them x comma y. We're given that we have a point 1 comma 0, and the question says, can we find this distance? Am I right? Making sure I remember it. Can we find the distance from any old point to the point 1, 0? And if so, what is it going to be so that it's only a function in terms of x? Okay? Do we know a formula that helps us find the distance from one point to another?
Slope form.
Slow.
Distance formula seems to make sense. Distance formula says if I do x minus 1 squared plus y minus 0 squared, that would be the distance between the 2 points, right?
No.
What is the problem here? We have the y here. We don't want the y here. Do we know what y equals?
You can figure it out.
Right here it tells us y equals square root of x. So what can we do? Plug it in. So
Square root of
x squared minus 2x plus 1, I'm just kind of foiling it out already, or multiplying it out, plus y squared, but it's really just root x squared. You guys with me?
Yes.
If I clean things up, root x squared becomes just x. If I add that with negative 2x, I get x squared
Wait, but there's
minus
multiplication.
x.
I mean, there's addition.
plus
Not
1.
to that specific thing.
I'm just combining like terms.
Crazy.
And then this would be our function that models the distance from any point to 1, 0.
We got Mr.